Hello,
Hello,
Volodymyr. Yeah, how
hello,
are you
do you
today?
hear me? Yeah, I'm fine. That's a great opportunity to listen such interesting ideas and such interesting approaches from other engineers. It's a good experience, I hope, for everyone who join us today.
Yeah, we also hope for this. So, you are going to talk about challenges of data collection from embedded devices, right?
Yeah, sure.
Yeah. So, if you're ready, please start your presentation then.
Yeah, let's start. Hello everybody, my name is Volodymyr Skochko and I'm a software engineer at Skochko.Company. Today I want to discuss challenges and solutions that may face during data collection on embedded devices. So we should start from the definition. What data collection is? We will use the following one. Data collection is a process which allows to collect data sets from real devices during alpha or beta stages of development and testing. This data may contain video data, radar data, data from different sources, sensors like GPS coordinates. It also may contain device settings or hardware configurations. In other words, if you develop algorithm for a new device, you may want to have some sets of input data to check algorithm feasibility, performance, and so on. Usually this data collection process contains some of the following steps. Uh, you get data from some data source. You modify or format this data if needed. Then you split data in portions and merge with data from other sources. And after that, you try to transfer data to some endpoint. You can support different endpoints like file system, some local storage, or even a remote server. And after that, you may process data to obtain data sets in the desired format. In general, we can consider two main types of data, raw data and process data. Actually, there is no sharp edge between these two types, but we just call the data raw if it is not processed enough in terms of our algorithm. So let's consider some example of data collection. Let's suppose that we want to develop some algorithm for automobile application, and this algorithm has the following inputs. Sequence of GPS coordinates, some video stream, and some data from navigator database. And based on that inputs, we should give user some suggestions. Of course, you should not drive for thousands of kilometers each time when you change some coefficient in your algorithm. That's why it is natural to prepare some raw inputs that will be used for the development process of algorithm. Also, you may do some iteration during data collection. So you can collect data, prepare some basic algorithm, then extend your data collection with some intermediate result from the algorithm, and perform another stage of data collection. So it will allow you to improve your algorithm step by step. And now let's enumerate why do we need data collection. So the first one is algorithm correctness check. The wide range of data sets allows you to analyze a situation when your algorithm works incorrectly. Of course, in real cases, algorithm can give us some false positive results or false negative results, and depending on product needs, the algorithm should be balanced accordingly. So data collection gives us inputs to simplify this procedure. The second one is data collection can be used to prepare inputs for machine learning. So you just collect the data and then you can prepare some expected output and use it as input for machine learning. The next one is that data collected in different use scenarios allows you to check your hardware units. You can check what the real data rate can be obtained from the hardware unit in different conditions. And that's why sometimes data collection may uncover such problems as overheating or performance issues. The next one, we can perform data collection to understand what is optimal configuration should be used for some hardware unit. Also, we should note that data collection always adds some additional system load on your device. So it may be considered as some kind of stress test. This can help you to find some bugs like race conditions and so on. The next one is debugging. Actually, during data collection, you can get data sets that contain much more information than regular logs. Of course, it will allow you to debug faster and you can understand what's going on for such type of bugs. And the last one is automated testing. So if you have stable data collection infrastructure, then you can simulate different scenarios and create automated tests. For example, you can play video on display and you can get the same scene for different builds. After that, you can develop some metrics to compare data from different builds, and based on that, you can improve your continuous integration process. Now let's understand why data collection on embedded devices is always a challenge. The most common reason is the fact that different resources are strictly limited on this type of devices. Let's enumerate some of them. Storage. A device usually has not enough memory to store result files on its own file system. Second one is network interface. Some devices may have only Bluetooth or mobile internet connection only. The next one is bandwidth. Maximal bitrate of data transfer can be limited due to either interface limit or weak connection, which may be caused by conditions. By conditions in when you use this device. The next one is RAM and CPU. We usually use energy effective chips, but on the other hand, these chips have lower performance, and that's maybe the big restriction for your data collection process. And the last one here is power consumption. If your device uses some internal battery as the main power source, then you may face with additional limitation on your data collection. So let's go to the next. Next one is Data collection infrastructure. It is the key point of good data collection, and depending on different factors, we can choose one of the following model. So we can use internal memory of device and perform async upload after data collection will be completed. Another model is to use device RAM and collect some amount of data, then group it to chunks and transfer these chunks. And the last one, we can use device RAM and continuously transfer the data if our memory is too small. Um, let's go to the challenges and solutions. We will give some short description for each challenge, and we will propose some list of solutions. Okay, so we are back to our presentation. So let's proceed. So now we will consider different challenge and provide some description for each challenge and possible solution. The first one will be ensuring security and privacy. In context of data collection, this challenge is not related usually to any personal data. It is mostly about some information that we are not interested in during data collection. For example, we don't want to have some faces or car numbers on videos, or we do not need a real GPS coordinates because we are interested only on delta values as an input for our algorithm. And another aspect of this challenge is that collected data may contain some intermediate data from our algorithm, and we do not want this data to be stolen because this will allow to hack our algorithm. So we propose the following solutions to this challenge. The first one, use internal beta testing and data collection. So if you use devices of guys from your company, then the risk to violate this security and privacy will be decreased. And the second one, you can use a local network connection only. This will eliminate almost all attacks to your data. Another thing, you should use secure protocol for data transfer to have your data safe. Also, you can use some synthetic scenes. You can prepare some special rooms or decoration or other things to emulate the real scenario and collect data based on these scenes. Of course, in this situation, you will get some limited range of data sets, but you will be able to ensure security risk. And the last proposed solution is to blur, normalize, or filter data to anonymize it. So let's go to the next challenge. The next challenge is scaling and support of new devices. We may want, usually we may want to increase device pool for current data collection, or we can want to apply our approach to the brand new device. and these have some potential risks because our infrastructure may not be ready for such a big amount of devices. We propose the following solutions. We can use a separate service on firmware side that will be responsible for data collection. In such a way, we will encapsulate the logic related to data collection, and it will be easy to migrate data collection solution to another device. Also, during infrastructure design, you should estimate and discuss data collection targets properly. You should understand what amount of devices will be used for this data collection. And of course, after that, you should use some x2 or even x5 coefficient for that amount to be sure that your infrastructure will be ready for this change. And the last solution here is to unify data source handling. So you should design your program to have some common API for different data sources. This will simplify adding new sources and modifying already existing data sources. Let's go to the power source challenge. The power source challenge is very common when you do data collection on embedded devices. We may need to avoid high energy consumption, especially for devices that use internal battery. And to solve this challenge, we can perform some of the following steps. First, we can use some additional external power source to support data collection. In such a way, we will be sure that our device will get enough memory, we will get enough energy. The second one, we can send files or store them to file system depending on our battery state. So we can check what is the current state, and based on that choose different transfer. Also, it is reasonable to introduce an idle state for your data collection service and use this idle state in the periods with useless data. Sometimes we have situation when almost all time nothing happened and this data will not be interested for our algorithm. So we can limit energy consumptions for such time intervals. The next one is very similar, is collect data only for certain events. So we just focused on some triggers like button press or detected motion or something like that. And we collect data only during these short periods. And the last possible solution here is to decrease data frequency. And let's go to another challenge, is data multiplexing. Usually drivers allow only one client for data to avoid copies or increase performance. But when you try to collect data alongside with working algorithm, of course you will need one more client to get this data. So we can do the following steps. First is to create a generic wrapper for data multiplexing. So you can write multiplexer server and multiplexer client classes and reuse these classes where needed. And the next one, you can try to disable a regular clients of data if possible. So sometimes we can do that. Sometimes we can turn off some features during data collection. And the next one is to try to unify source code for both data collection and regular firmware. And you should try to do it as much as possible, because it will allow to maintain your source code properly and to support this code. And the last one is to implement multiplexing on driver level. So if it is possible, then it will be useful not only for data collection, but maybe for some upcoming features or service that may use the same data. Let's go to the next one. Also very common thing, very common challenge is bandwidth. Due to software and hardware limitations, we cannot send all desired data. And on the other hand, we may face some situation when network is unstable for some short periods of time, and we may lose some parts of collected data. We propose the following solution. First one is to decrease data frequency. The second one, you can split data into smaller parts. In such a case, if you even lose some data, then it will be just a small part, and this loss will have not so big impact on data collection results. The next one is to send data only related to some events. Also, it is reasonable to define some minimal requirements for devices that should be used during data collection. You can use, for example, average network speed or something like that. And based on these requirements, you can filter devices. So you choose only good devices. Another way is to use another device like laptop. You can use it as an intermediate point of your infrastructure, and you can send data from device to laptop via local network, and after that laptop will upload the data to endpoint. The next one is to send critical parts of data first. So you can understand what the data is the most important one, and you should prioritize it and send it first to be sure that nothing critical will be lost in case of problems with network. And the last one, compress data if possible. Of course, it very depends on your hardware, and you can check what your device can do with data compression. And the next one is the next challenge is architecture and design. So usually data collection firmware based on a regular firmware, and this may cause issues with the code base. The most common of them is a big amount of if-defs and unnecessary dependencies and so on. To manage this risk, manage this challenge, we propose the following steps. First one is to create a separate service for handling data collection tasks. Also, you should review and extend your architecture to support data collection in parallel with the regular one. Very important step, if you plan to add a new sensor or feature or algorithm, then you should plan what data collection should be done for it, and also you should understand how this new feature impacts data collection process. Another one is to use lightweight wrappers to access raw data. This will give you some API and it will simplify your architecture. Also, you should, of course, review and optimize memory usage and avoid unnecessary copies in your data collection code. And the last one here, you should properly design communication and dependencies between components. Let's go to the next challenge. The next challenge is data collection conditions. Result data sets can be useless if they are irrelevant for some expected use case. So if you plan to use your device in both Arctic zone and equator, and you collect data only with positive values of temperature, then you may face with some big surprises after release. So the main idea of this challenge is to cover all possible conditions as much as possible. We propose the following solutions. First one is to define corner cases for your algorithm. So you should understand what is the limit of temperature or humidity or something like that. And the next one, you should prepare synthetic scenes for data collection to cover some of those corner cases. And the last one, you should choose your beta users to support as wide range as possible. So you should check some weather condition, location, luminosity, and even device usage style, because it may be important for the quality of data. The next challenge is relevancy of collected data. Actually, not all collected data can be used for further steps. Some data sets can contain corrupted or even incomplete data. To mitigate these risks, we propose the following solution. First of all, you should introduce some data quality metrics to filter those corrupted data sets. Also, you may add some extra info to data with relevant errors that were present on firmware side during data collection. Another possible solution, do not send incomplete data at all. So you may filter this bad data on device side. And the last one here is you should perform a retrospective of already completed data collections. It will allow you to understand some corner cases, some gaps in your infrastructure, and so on. And the last challenge is data conversion. So usually collected data does not satisfy the target algorithm input format. Usually this is caused by low performance of device. We cannot adjust a format properly because of limited resources. So we proposed the following two solutions. The first one is to define formats properly and carefully to balance device capabilities and requested format. And the second one is to add conversion logic to the receiver part of your infrastructure. Also, you can you can do some filtering or data adjustment on the receiver side. It allows to decrease system load on target device. So let's go to some results, some summary and conclusions. What should be done before data collection? So first of all, you should analyze what data should be collected and where it should be stored. Also, you should estimate both maximal transfer bitrate for device and expected data bitrate. You should design data collection logic at early stages of new features design. You should analyze the range of conditions for which data should be collected. And also you should focus on data collection only during some useful periods, if possible, of course. So you should not collect 24/7 if you don't really need it. And the last one is combine different approaches and models to perform your data collection. And here we have some notes. First one is there is no silver bullet. Data collection is always a balance between requirements and device capabilities. And the second note is retrospective is the key to get better results for your data collection and for upcoming data collection processes. And the third one is infrastructure design is the key point to develop algorithm and to develop your firmware for new devices easily. Thank you for your attention. So that's all from my side. I want to add that during question and answer session, we should have few gifts from Squad company. So should be interesting for you to ask something.
Yeah, Volodymyr, thank you so much for your talk. Since we have couple minutes and one question in the chat, and I would like to ask this question now, and then you can continue the discussions in the Zoom room. So the question from the chat is, do you use any custom services or any known services for collecting, analyzing, and storing data from devices?
Actually, at Squad company, we are using our own infrastructure, our own services. But of course, it really depends on your device, on your data. If you have small data to be collected, so if you do not collect video or LiDAR or radar data, so you can use some already existed solutions, but it's not our case.
Okay, yeah. So thank you so much. There are no other questions in the chat right now. But I invite you and participants to continue discussion in the Q&A Zoom room. You will find link to this Zoom room under the broadcast and chat of the track 2. And as Volodymyr said, the best questions will win the prizes from Squad company, so please join and have a live discussion there. Volodymyr, thank you once again. Thank you so much for your participation. We appreciate a lot that you supported Embedded Fest this year.
Thank you too.
Yeah, have a good day.